What's up, legends? We're here, Big Daddy Miles. You know, we got Big Buddy, and last but not least, we got Corey Sanchez, and we're gonna be talking to you about some concepts. Let's go check it out.
Non-axial. In gliding joints, the bones simply slide in relation to each other. Therefore, there are no axes of rotation in this type of joint.
No one.
Begin.
Uniaxial. In hinge joints and pivot joints, there is only one axis of rotation. This means that the structure of the bones at the joint restricts rotation and movement around only one axis. Biaxial. At condylar joints and saddle joints, there are two axes of rotation, and therefore the bones can move in two different ways. Triaxial. Ball and socket joints such as the shoulder and hip allow rotation around three axes. Therefore, these bones permit the greatest movement as they allow the limbs attached at them with a large volume of space.
The sagittal plane cuts the body from left side to right side. The frontal plane cuts the body from the front side to the back side. The transverse plane cuts the body from the top half and the bottom half.
Flexion, closing of the joint angle around the transverse axis at the joint.
Extension. Opening of the joint angle around the transverse axis at the joint.
Abduction, opening of the joint angle around the frontal plane. Adduction, closing of the joint angle around the frontal axis at the joint.
Medial or inward rotation. The anterior surface of the moving bone moves towards the medial inside aspect of the body. Lateral or outward rotation. The anterior surface of the moving bone moves towards the lateral or outside aspect of the body. Dorsiflexion, flexion of the ankle joint.
Go.
Pronation. Medial rotation of the radial ulnar joint. Supination. Lateral rotation of the radial ulnar joint. Eversion. Medial rotation of the ankle joint.
Look at that ankle. Look at that ankle.
Inversion. The lateral rotation of the ankle joint. Horizontal abduction and adduction. Opening and closing of the joint angle around the transverse plane.
The shape of the surfaces of the articulating bones in the joints. The effects of the muscles and tendons at the joint. The amount of soft tissue, skin, fat, muscle at the joint. Concentric contraction. If the ends of the muscles are actually drawn together, this will result in the movement of one or more body segments.
Isometric contractions. If the muscles contract, but the rotational effect of the muscle force, muscle technique, or movement is exactly equal to the provided by the resistance.
Eccentric contraction. If the muscle is contracting but the rotational effect of the muscle force is less than that of the resistance, then the ends of the muscle actually get further apart.
Eccentric and concentric contractions are sometimes known as isotonic contractions because the force remains constant during the movement of the body segment affected by the muscle.
Isokinetic motion. Isokinetic motion is when a muscle contracts so that the body segment to which it is attached moves at a constant speed around the joint.
The muscle contracts concertantly to move the bone relative to the joint.
Antagonist. If a muscle contracts eccentrically, then it is often acting as an antagonist for the joint action.
Fixator. When muscles contract, both ends are drawn towards the middle of the muscle.
2.
Synergist. Most muscles have more than one action of a joint. For example, just kidding, we don't need examples.
2.
Now, for the bloopers.
Lateral or outward rotation.
Hey Corey, how about you take off your shorts?
That'd be so gay.